Hello everyone, my name is Muhammad Shahid Munir, a PhD student in Sangungan University. I am presenting today AEON, Adaptive Embedding Optimized Noise for Robust Watermarking and Diffusion Models. This paper is accepted in WACV. My topic for today is AEON, and which is uh, uh, watermarking technique. As we know, AI generated contents are becoming rapidly increasing and they are becoming more useful these days. People are using it easily and anyone can generate images that are highly realistic and hard to detect through naked eye. They are realistic and they are widespreading everywhere, and that's why we need a robust watermarking technique that do not compromise the image quality and also retains the watermark and can verify the authenticity and protect the copyright of the generated content. There are two different types of watermarking methods, post hoc methods and in diffusion methods. Post hoc watermarking methods embed watermark after the image is generated, while in diffusion watermarking generates image watermark, embeds watermark during the generation process. So both types are vulnerable to adversarial attacks, and performance degrades when we combine different all of the attacks and mimic the real world editing. Adaptive watermark is embedded in AEON, while existing methods such as Robin embed a static uh, watermark that is visible when we embed in later diffusion space steps. So AEON consists of three stages. And in first stage, we train hash network. In second stage, we embed watermark. In third stage, we verify the watermark. In first step, we have a hashing network that is trainable, and we take in HT, that is intermediate noise, with T injection timestamp, where we you take XT from intermediate noise, and then we use this XT to train the hash network, and with the hash network we generate a hash that is trained with different loss functions that will be discussed later. In step 2, we have adaptive watermark generation, where we use the same hash network that we train in step 1, and this hash network takes in HT, generates a watermark hash, and that watermark hash is then blended into the intermediate noise through Fourier transformation, and then IFFT operation, and then we continue with the further generation of the image. At the final stage of the watermark generation, intermediate image generation process, the watermark image is generated that is containing the XT watermark Fourier space within, which is blended within the image and infused into semantics. We mimic a reconstruction attack, and the reconstructed image is then used. Let's say we use to extract W, that is the watermark noise, from by using inverse GDM and FFT process that is taken from the Robin and existing methods. And then we compute the difference of this extracted watermark with the existing watermark that we have, watermark for that we generated in step 2. For experiments, we use diffusion model, that is V21 base, which is a guided diffusion model. For training hash network, we use MS Coco, and for prompt dataset, we use existing dataset that is Kustowaska. We are from Robin and Treating, so that we can compare with them exact same thing. For generation parameters, we use 50 denoising steps, where we embed the watermark at the stage 40 for better results. And guidance scale we take in 7.5. For image dimensions, we took 512 by 512 image dimension. We use DPM solver for noising denoising, and we generated 1,000 images for the evaluation of the proposed approach. As far as the hardware is concerned, we use NVIDIA A140GB. We use hyperparameters for alpha, we use 0.9. For gamma, we use 0.4. Hash generation training takes in learning rate of 5e minus 4 and batch size of 16 with a max step 2000 and seed of 42. To ensure the watermark presence, we use performance measuring metrics like AUC for measuring the performance of all possible thresholds. And for accuracy, we use accuracy for correctly detecting the watermark. We use TPR at 1% FPR for true positive rate, and false positive rate is 1%. We use SSIM, which is structural similarity index, for computing the image quality to make sure that it follows the image follows the structure of the original image. We use peak signal to noise ratio (PSNR) for maximum possible power and noise. We used MSSIM for that is the extension of SSIM to multiple scales. We use FID for measuring the similarity between feature distribution and compare statistics of real and fake watermark image. Here, lower FID indicates better fidelity. For prompt alignment, for the prompt to make sure that prompt generated image aligns with the prompt, we use clip score that indicates the better alignment of the image with the higher score. We use the attack scenarios where we take in the traditional degradation attacks, which includes noise brightness, crop rotation, and JPG compression. For reconstruction and adversarial attacks, we use BM3D, SJ18, Zahao 23, and Chang 20. These are the works that earlier used. We introduce another attack that combines all of these attacks and creates an image which is combined all of these attacks. And this mimics the heavy editing that the image goes through during the sharing and sharing the image on the social media and other platforms. Here, ION shows robustness against all attacks as well as the cumulative attacks. Existing methods reduce their robustness when we test their model on cumulative attack that we present, and this combined attack actually reduces the AUC by 4% on Robin, while our method retains the robustness against that attack. So AUC against different reconstruction attacks shows better performance than existing methods, and cumulative attack shows better performance than all other methods, while existing methods fail when we apply cumulative attack. To assess the image quality, we plot this figure where we can see that tree have lower image quality, but Robin, despite having a better image quality, it lacks the intrinsic details of the image. However, the ION is giving better quality that resembles the original image more in semantics. The watermark quality reduces in Robin, where the watermark, when injected at later stages, shows visibility on different areas highlighted here. While ION, since it embeds watermark within the image, uh, in within the image semantics, it actually fuses it and increases the image quality and retains the watermark when applied different adversarial attacks. We did some ablation study on different parameters, including the steps. When we embed watermark later steps like 35 and 40, the image quality keeps increasing and the robustness keeps increasing. This was given by the Robin paper, where they discussed that when we embed watermark in later stages, we can preserve AUC and PSNR, that we observe the same phenomena in a hash that is embedded into the image, and it shows resilience against different adversarial and traditional degradation attacks. It gives a high perceptual image that is very close to the original image. And that's all from my side. If you have any question, thank you for your attention. And if you have any question, you can talk to me, give me an email here. Thank you.